All right, friends, welcome everybody. Welcome to yet another webinar from Data Platform Geeks. And before I hand over the stage to Niels, friends, I'll just take a moment and quickly talk about today's webinar. So today's session is Let SQL Server be the central hub for all types of data. Before we begin, let me just take a moment to talk about Data Platform Virtual Summit. I guess by this time, all of you already know about this mega event that is just coming up round the corner, probably just 3 to 4 weeks away. I think it's exactly a month away because this is 12th August and we are kickstarting on 13th of September. So a month away. And I want to put a special focus on our training classes. And just like last year, we are building on top of that. We have got some of the world's best trainers and have lined up 15 training classes for you. We call them as pre-cons and post-cons. Pre-cons happen before the summit and post-cons happen after the summit. One of the biggest announcement here is if you take up a training class, you get a complimentary pass for the summit. Not only will you be able to attend live, but you will also get all the recordings. So, the full session content of 130 sessions, breakout sessions, you will get recordings of that. We have lined up 15 classes for you, and you can see we are trying to cover the complete stack of Azure data analytics and AI. You have class on machine learning, AI, modern data deployment, managed instance, execution plans. We are covering Power BI, DAX, big data clusters, PowerShell, data deployment and implementation, DAX, data visualization, SQL Server, both from admin and developer perspective. But the special focus goes to, because today Niels is with us, let me take a moment and talk about this class, which is Big Data and Analytics with SQL Server 2019 Big Data Clusters. And I will not be the right person to talk about the content that Niels is covering, and that's why Niels is here. Maybe he'll take some time before the webinar or after the webinar and talk about what exactly is he going to cover in this class. This is an 8-hour class split into 2 days, 4 hours each day. And as I mentioned, you will be able to attend live and you get the class recordings 12-month streaming access so that you can rewatch the class all over again and again, as many times as you want. Take a note of this discount code SAVE20. If you punch in that discount code, you will be able to save $20 when you book your ticket. Friends, at Data Platform Virtual Summit, our focus always since the inception has been on content. We've tried our best to bring you fresh content, and that's why we call them as freshly baked sessions. In the virtual world, it's very easy to get a lot of content that's easily available on the internet, on YouTube. So we've tried best that you get the latest stuff from world-renowned experts. About 120 sessions have been announced, and we have an amazing mix of speakers from Microsoft, from the community. And when I talk about the community, we have data platform MVPs and industry experts. So it's an amazing panel of speakers that we have for you with some great content. Another big announcement, just for next few days, probably another 3 to 4 days, you can book a complimentary pass for Data Platform Virtual Summit. What we did a few days back was upgraded our platform capacity, the virtual conferencing platform, and we added another 5,000 seating capacity. So go ahead and book a free seat for yourself. Yes, absolutely complimentary. You don't need to book a training class, nothing at all. Just register and you will be able to attend live. But remember, if you book a training class, you also get the recordings as well. So the link is there in the chat window, dataplatformvirtualsummit.com. Well, with this, this is the last slide for DPS. So go ahead, talk to your manager, get sponsored, and pick up the training class that suits your needs, your project, your career options, whatever. Well, with this, over to the rock star, Niels Berglund. Niels, thank you so very much for joining us once again and partnering with us. We really value your time, and you agreed to do this webinar for us. Over to you.
Thanks, Amit. Once again, it's a pleasure being here again. Let's see if I can share my screen here. So once again, welcome to Data Platform Geeks webinar. Let SQL Server be a central hub for all types of data. So this is kind of a precursor to my training class in a couple of weeks' time. Here we will just have a quick overview of what SQL Server Big Data Cluster is. So this session is about SQL Server Big Data Cluster. As you can see on the slide, I'm Niels Berglund. I'm software architect lead in sunny Durban, working for a company called Arivco. Durban is in South Africa. Well, you guys know that you know geography a lot better than I do, but anyway. And I'm also a data platform MVP. So let's see. Before we drill going down into what we're going to talk about, what this is all about, let's talk a little bit about data. I'm kind of a data nerd. I've been working with SQL Server since version 4.1. I'm probably showing my age saying that, but anyway, so data is a passion. And here are some, when we think about data, here's some quotes from a book called Tools and Weapons, the Promise and the Peril of the Digital Age, written by Brad Smith. For you who don't know who Brad Smith is, no, he's not a software developer, but he is the lead counselor at Microsoft, been with Bill Gates and Satya since day naught almost. And this is an awesome book. So if you're interested in data, if you're interested in what Microsoft is doing with Azure, etc., go and buy this book. This is not very, very technical, but it deals with, he talks about the Azure data centers. He talks about being compliant. It's extremely interesting. So there are some quotes in that book that I have captured here. So civilization has always run on data. If you think about it, that's the case. Ever since Moses came down, he had his tablets. They were not iPads at that stage, but they were like stone tablets, as we know, and those contained data, right? And well, we all know this. Every aspect of our life is now fueled by data. Wherever we go, people have information about us. If we're on Facebook, if we're on LinkedIn, if we're on Twitter, people know what we are doing. And as opposed to like oil, we know that at one stage or another, the world will run out of oil. Fossil fuels will be gone. Data is the opposite. Well, not opposite, but data is a renewable resource, right? So we will never, you should never say never, but I can almost guarantee that we will never run out of data. And if we think about it, right, so 2020, beginning of 2020, the world was hit by COVID. Did the flow of data slow down? No, it continued. It sped up, and we have a lot more data now in August 2021 than we had in August 2020. And here's just some numbers around this. So we generate more and more data, obviously. There have been some research done. I don't know how they've been doing it, but been some research done where they have said that in 2016 we had around 16 zettabytes worth of data. Zettabyte is a large number. It's a trillion. Well, it's huge. It's huge. Anyway, but in 2025, in 9 years' time, we will have more than tenfolded that number. So we are sitting with 163 approximately zettabytes worth of data. So the data, we are getting more and more and more data. And the thing with all this data is that this data is not stored in a cool database like SQL Server, for example, or God forbid Oracle, or some other relational data store. This is stored all over the place in a variety of types and forms and shapes. And then comes the question, how do we manage all this data? Think about this, that we have to manage all this data, because if we don't manage this data, someone else will. our competitors will come in and essentially eat our lunch. So data has become a very, very precious commodity. And we need to be able to handle it. We need to be able to analyze it. We need to be able to get insights into the data. And that's what this talk is about, and also what the training class in a couple of weeks' time is all about as well. So once again, how do we manage all this data? And what Microsoft wants, Microsoft has had a look at this, and they have seen the evolution of SQL Server, how it went from a fairly, well, not so good relational database system back in the 4.1 days and the 6.0, 6.5 days up until what it is now. And if we think about it, how it has evolved, right? We had first a relational database system, not that good. Then as time went along, there were evolution of SQL Server. Microsoft introduced SSIS. Microsoft introduced Analysis Server. Microsoft introduced in SQL Server 2005, which was, in my mind, a huge release. Microsoft introduced SQL CLR. I love SQL CLR. I can abuse SQL as much as I want with SQL CLR. My DBAs don't really like me, but hey, that's their problem. So SQL CLR was introduced. XML data type was introduced. In SQL 2016, Microsoft introduced the ability to run R scripts in SQL Server, or rather execute T-SQL code that called out to an external R engine, and we could execute R scripts. Right? In SQL 2017, Microsoft added Python to the mix, so we can now run R or Python, execute R or Python scripts in SQL Server, and those scripts are being executed outside of the SQL Server engine. At the same time, around SQL 2017, the unthinkable happened. What do I mean with that? Well, Microsoft went Linux. We could now, in 2017, we could spin up SQL Server in Docker running on Linux. Wow, how things have changed anyway. Right? Then in 2019, for SQL Server 2019, Microsoft added the ability to execute JavaScript together with R and Python in SQL Server, and we can run SQL Server on Kubernetes. Once again, SQL Server on Linux, running in Docker containers in Kubernetes. I mean, so we can see that SQL has evolved, and Microsoft here now sees this evolution, places SQL Server right smack in the middle to be able to be the central hub, to be the intelligence over all your data, not only relational data. So here we're talking about, and what will accommodate this, what will make this possible, is the SQL Server 2019 Big Data Cluster. And so what is SQL Server 2019 Big Data Cluster? Well, it is SQL Server, but it is not SQL Server as you know and love. This is SQL Server coming with SQL Server, you get Apache Spark, you get Hadoop, you get a lot of stuff in the box, right? So in essence, SQL is the SQL we know is a very, very small portion of a big data cluster. And the reasoning behind this is so that we will be able to extend, or that Microsoft will be able to extend SQL Server to store data in a petabyte range. And we, by now having HDFS, Hadoop file system in the box, we can also store non-structured or semi-structured data, i.e., well, big data, all out of the box. And this runs in Linux containers on Kubernetes. Right. So let's have a look at the architecture of this. I will just show you this picture. I have previously used a much scarier picture. This is the least scary picture I could come up with, where we are seeing, well, let me see if we can. So all this here, right, that's Kubernetes. And in Kubernetes, we have something called a control plane. So over here, we will not talk about it. I'll come back to this in a second, but then the rest to the right here of this line, we have the SQL Server part, where we're seeing that we have a SQL Server master instance. So this is not the master database. This is an instance, right? And that's kind of what we see here, SQL Server master, and that is your normal SQL Server that you are installing, that you are running. Everything else here, then we have something called a compute pool, we have a storage pool, we have a data pool, and we also have something called the app pool. And that is now part of the SQL Server big data cluster. And in the coming slides, we will talk a bit more about compute pool, storage pool, data pool, and we will not talk about the app pool. And I will not go into details around Kubernetes and how SQL runs on Kubernetes, but I'm going to throw Ben to the throw Ben under the bus here, Ben Weisman. He is on the call. He is a master of SQL Server Big Data Cluster, as well as SQL on Kubernetes. And Ben, together with Anthony Nocentino, I think it's pronounced, is running a training class around SQL on Kubernetes. So if you if you're interested, make sure you're going to that training class. Ben is awesome, and he definitely knows what he's talking about. Right, so how do we now deploy a big data cluster? Well, as I used to say, we're not in Kansas anymore, right? So I don't know about you guys, but usually when I deploy SQL Server, I have an ISO file. I have downloaded an ISO file, I mount that ISO file, and I click setup. And that's that. Not so much here. Here we are deploying via Python scripts. So there is a shed load of Python scripts that we can run to deploy a big data cluster. We can also, if we are lazy as I am, or in a testing scenario, we can also deploy from Azure Data Studio, where Azure Data Studio, as you know, they support the notion of notebooks, and there is now a big data cluster notebook that allows us to deploy a big data cluster from Azure Data Studio. So let's see. Jesus, there we go. So here's Azure Data Studio. If I click up here in the left-hand side, we can see new deployment. Cool. We click there, and then we are now getting some options what we want to deploy. So if you want to deploy a SQL Server Big Data Cluster, you click on this, and then you follow the prompts. Right? Cool. And during deployment now, you have the ability to say how many nodes you should have, how beefy should the machines be, etc., etc., etc. And just be aware, initially, when BDC was introduced, there were documentation saying that you could install this on on a laptop, on your laptop, right? That was a lie. That was a huge lie, unless your laptop has like 64 gig of memory and huge hard disk space, etc., etc., etc. And having said that, so where can I now run my BDC? So you can essentially run your big data cluster on any Kubernetes installation. I happen to install it in Azure Kubernetes Service, because that is the easiest way to do it. I believe that when Ben and Anthony is doing this, they are hardcore, as I said before, and they are installing on bare metal on-prem and having a lot of fun doing that. But you can essentially run your big data cluster wherever. Amazon, Azure, Google Cloud, on-prem, as long as you run it in a Kubernetes cluster. Right, so how do we manage a big data cluster then? Well, we are using command line tools, and there are 3 command line tools that you would use here. It's a kubectl, kubectl. I still don't know how to pronounce it properly. Kubectl is sort of a Kubernetes control tool. Kubectl doesn't know really anything about big data cluster, but it knows about your underlying, about the Kubernetes cluster where your big data cluster runs. So let's go there, right? So what we can do here, so I have some pre-cut code. I have a cheat sheet. So we have a get pods SQL BDC / cluster. I think that's what I called it. So this. So when we are deploying something into Kubernetes, we are deploying containers into Kubernetes speak, what we call pods. So everything runs in pods in Kubernetes, and we can do kubectl get pods, and we're saying that the name of this cluster, or in Kubernetes speak, this is a namespace, but let's call it name of the cluster SQL BDC cluster. I really hope that's the name. And I was lucky. Here we can now see that here we have all the different pods that make up a big data cluster. And it's a lot. We have here something called the master pod. And that is where your SQL Server instance runs. We have, in a BDC, we have more than one SQL Server instance running, but the sort of the OLTP SQL Server, the server that you are communicating with, lives in this master-0 that I just pointed out here. So what we can do is we can is do something like this. I can ask for, I'm just copying some code here because you really don't want to see me type. We can say get pods master. So give me the master pod in the SQL BDC cluster, and then give me the various containers. So I said before that in a pod, there are containers running, right? And if we are executing this, if the demo gods are with us, we can see that there are 3 containers running in this pod: MS SQL Server, collectd, and FluentBit. The collectd and FluentBit is something that comes with Kubernetes. It's there to collect logs and do stuff. I will not go into that. Ben can talk to you about that if you want to. But the interesting one here is now the MS SQL Server container. So this is now the container. So if you were to run a Linux SQL Server container, that's the container that you would run. Right. So what we then can do, just to show you that I'm not lying to you, we can, through this kubectl, we can go in and we can go into the actual, into the pod, or into the container, MS SQL Server container, in the master 0 pod, and execute the bash script. And I hope you can see what we then can do is we can do a cd into var opt MS SQL, so not ns, MS SQL log, and here we have now seeded into the log file directory of SQL Server. And if you were to go into any SQL Server instance and go into the log directory, this is kind of what you would see. So this is, yes, this is actually SQL Server. Right, cool. So we have shown that that is the case. Let's go out of here. Let's do that. And then what we also can do, so kubectl doesn't really know anything about SQL Server as such. What we are, if we want to deal with the big data cluster and SQL Server from the command line, what we are using is we are using a command called AZData. And AZData knows about BDC. So here we can run, here I'm just now running a command saying, for the BDC, give me a list of all the endpoints, right? So the various services in this big data cluster is, oh God, sorry. So I need to log in. Actually, we BDC cluster, sorry, admin, and then my super secret password. Cool, and let's try it again. Oh, sorry, God. There. Okay. So the various services in my BDC are exposed through endpoints. And by talking to this endpoint, I can now do various things. So we have a gateway here to access HDFS files. We, let's go down to, come on. Here we go. So here, this dude here, right? This is now what you are connecting to when you connect to your SQL Server. You're connecting to this 102.133 yada 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 port 31433. So that's kind of the connection point to SQL Server. And through this connection point, you can also get to HDFS and all the other cool stuff in SQL Server. Right. Yes, so cool. So that was the sorry, that was the architecture, a very, very whirlwind tour of the architecture. So how now integrate and manage data? Right, that is then what we want to do, and then we want to analyze data. But how do we integrate and how do we manage? And the one part of this whole integration and managing data is data virtualization. So if we think about it, right, previously quite a lot what we are doing is we have a system sitting somewhere, And then we have another system which may be where we are running reports from. Quite often what we are doing is that we are moving the data from this source system to the other system. And that is wrong on so many levels. First of all, it's data movement. It's network bandwidth. And I don't know about you guys, but my security guys, they are kind of a little bit, they don't like it when you move data back and forth. So sometimes you have to, and there are reasons you have to, but if we can virtualize the data, that is cool. And if we then look at the data virtualization in SQL Server, we started back in the day with linked servers, and I do have a sad face there. Linked servers don't have the best street cred. I had to resort to write a new linked server implementation using SQL CLR when I joined Derivco back in 10-15 years ago. So linked servers is a way to do data virtualization when I can call into a remote site and grab data. Polybase is something that was introduced in APS, the analytics platform system, which eventually became SQL Server Data Warehouse. And Polybase shipped outside of the data warehouse first time with SQL Server 2016. And the data warehouse added features to Polybase that then was rolled into Polybase in SQL 2019. So Polybase is, well, a way to get to external data. And the way we are working with Polybase is through external tables. So this external table lives in the SQL Server master instance. Once again, your SQL Server instance, not the master DB, but the SQL Server instance, and it represents a remote table or a remote view. And we are accessing this data as it was in our database, but no data is in that external table. All the data is in that remote table, and queries is being pushed down to the remote source. So if we look at this, actually, sorry guys, that's not what I wanted to do. I think I should have here somewhere. Yeah, I mean, talk about sacrilege. I have here up in Azure, I have a resource group where I have Oracle. I don't know what Oracle is. Someone is saying that is some sort of database system that some people work with, but I don't know. I have an Oracle instance. And if you guys are used to Oracle, you probably remember scott.emp. So if we can execute here, and everyone tells me how quick and fast and performant Oracle is. Yeah, let's try again. Come on. And this doesn't work at all. How cool is that? Right. So eventually we managed to do a select from scott.emp. So here we now have the famous emp table in the Scott schema, table schema, with all of 14 rows on it, right? So I have an Oracle instance, and now I want to do some sort of data virtualization, right? So I go into my database. Let's see that if I am not in my database. That's probably because it doesn't exist. So let's create my database, and there we go. And now I actually am in my database. So what we want to do here, so in my database called Nils database, I don't have any imagination, so that's why I call it Nils database. In my database, I now want to connect into my Oracle server, right? My Oracle DB. So what I'm doing, I want to create an external table. First, I am creating a master key. So my database needs a master key. So don't look at my super secret password. Then what I'm doing, having created my master key, so the master key is kind of protecting other stuff. Amongst that is what we call a scoped credential. So now I'm creating a scoped credential that I call Oracle Cred, that happens to have the same a login that Oracle knows and a password that Oracle knows, right? And we have created a credential. That credential is just created here now in my database. It doesn't know that this is Oracle. It doesn't care if this is Oracle or Sybase or whatever, right? We can check that we have it in credentials. Yes, we do. How cool is that? Now we are creating an external data source, which points to where my Oracle server is. And if you now are quick, you can actually connect to this Oracle server because you know the login name and the password. So let's create this external data source. There we go. We have created the external data source. And then here comes now the important bit. Now we are creating, having an external data source, having an external credential, we can now create an external table that represents my emp table. So where I'm setting it up with, I give it some column names, I'm telling it where it is, and I'm saying what's the data source. And there we go. We have created it. And now what I can do is I can do a select from it. And here we go. Here we now have coming back my 14 rows from Oracle. And I remember what I said, that queries are being pushed down. Okay, so what if I do this? Whoops. What if I do this, right? What if I do select top 5? I promise you, I will eventually get there. Probably on the 3rd try, because we know that version 3 is always the good version, right? So let's run that. So here we now have select top 5 from Ampora. You who know Oracle know if I did this and if I went into Oracle and ran that, God. Okay, once again, the connection is resetting. I can tell you, instead of waiting for this to work, I can tell you that if I did that, I would get the big fat error from Oracle, because Oracle doesn't understand top 5. But the query is still being pushed down, and it is translated into something that Oracle understands. How cool is that? Right, so that was an external table. Cool. So where Microsoft now says that SQL Server should be a data integration hub is in SQL Server 2016, through Polybase, we could access essentially big data. We could access HDFS, Cloudera or Hortonworks, and Azure Blob Storage, right? That's kind of where we were in SQL 2016. Now you have already seen that in 2019, we can We can access Oracle. We can also access Teradata and Microsoft SQL Server as relational databases. We can, from a NoSQL perspective, access Cosmos DB and MongoDB. And if we have ODBC drivers, we can essentially access anything that understands ODBC. Right. We also have the ability to scale out compute for performance reasons, and we'll talk about that in a second, how we are scaling out for performance. Right, and how we are scaling out is through this dude here, the compute pool, right? And the compute pool is a group of instances that can process complex distributed queries. And your SQL Server master instance, when you are executing a query, the master instance decides whether to call the compute pool to get better performance or not. And there are certain rules and regulations to when this will happen. And this compute pool contains one or more SQL Server engine instances. So when I said in the beginning that you are getting, when you're installing BDC, you're getting a lot more than just one SQL Server. You're getting a lot of SQL servers, right? And so in the compute pool, these servers are there mostly for compute. You may use local storage. So we are not using them for storage unless we need to do data shuffling, unless we need to save off some intermediate result to use at a later stage. So compute pool is exactly what it says. It is there for compute. What is more interesting here is the storage pool, where the storage pool is where you have both Spark as well as HDFS. Right? So HDFS, Hadoop file system. And this is now where you are storing your big data stuff. You can, in addition to have this HDFS in your BDC, you can also mount against other HDFS stores, as well as through Azure Data Lake Storage, etc., etc. So you can do remote mounts to get in other HDFS data. And we can now access this through both through HDFS as well as SQL endpoints. And let's have a look at that. Right. So if you notice here in my Azure Data Studio, here on the instance level, i.e. there, right, we have, let me make this a little bit better readable. We have something called HDFS. And this is now essentially the storage pool that I just spoke about. And under HDFS, we have various directories. And we have a directory that I called clickstream data, product reviews. Then we have a system directory. I have a directory that I call Titanic. And we have a TMP and user. And the system, TMP, and user, that sort of comes out of the box. The other directories is directories that you have, well, not you, me, you have created, and where you now can upload data to. So we can, new directory, DPS rocks, Data Platform Summit rocks. And I have now the ability to upload files into there. And that's how I have managed to get here this CSV file, that CSV file, and those CSV files into those directories. So have a look here at clickstream CSV. We can do a preview. And here is now I mean, we all know what this is, right? We can tell, we know what this is. So here's just now this CSV file. Right? And if we're looking at product reviews, we can do a preview. Come on. And here we have stuff. So the whole thing is here that now I have big data-like data at my fingertips inside big data cluster. And I now have the ability to treat this data as it would be normal SQL data, relational data. All right. So let's take that down. So what we're going to do here is then do just that. We're going to treat it as it is, sorry, as it would be SQL data. There we go. So what we want to do is we want to create a data source against this storage pool, because the storage pool is now where your Hadoop data is stored in SQL Server. And I want to give it a name called, once again, I've said before, I don't have any imagination. So I call it SQL Storage Pool. And the location here indicates to SQL Server that this is essentially this directory here. All right. So we run that. Then what I'm doing is, so this is no longer, I mean, your normal relational data. It can look a bit weird. So what I'm creating is I want to create a file format where I tell SQL Server how to handle this data. And there are a lot of options, how to handle it, etc., etc. I will not go into that because that would take the whole night. So we are creating a file format that we call CSV file. I mean, this is just a name. You can create it, you can call it whatever. We have created it. When we're looking here, I now have in Niels database, I have a file format, a name called CSV file, which is the limited text. Cool, that's what we wanted. Right, so then having this, I can now create an external table against this HDFS, against this big data, where I am setting up the external table. I give it a name. I define my columns. I say what the data source is and the location as it is on relative to the root, relative to this HDFS folder. Right? So I'm saying that this is now in clickstream data. Cool. So we run that. We have created it, and now we can do that, select top 10, and here we have now queried HDFS data, Hadoop file system data, like it was SQL Server data. And I can now do, what shall, we could do something like this, where WCS item underscore SK equals 4379. I have no idea. I really hope that I will get this back, but I have really no idea what I will get back from this query now. So there we go. And look at that. So here we have now queried this data as it was SQL Server data. And I can do joins. And I could now, for example, I could do a join against my Oracle data that I just had in my Oracle instance by joining my Oracle external table with this external table, right? So I hope you see here how easy it is to actually now query big data. I mean, I have been unfortunate enough to try to use Hive and all that good, well, not so good stuff. And well, I'm a SQL guy, so it's probably by nature that I'm saying that this is a lot easier, but this is easy, 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 easy. Cool. Right. So that was the storage pool. So here the storage pool gives you your data lake. Well, as long as you have enough storage, and this is just now normal HDFS storage. So it's very, very cheap storage that you then can query as it would be relational tables. The data pool is, I like it. I know that Ben likes it. There are other people that doesn't like it. So the data pool is when you, so now we have seen about the storage pool, but sometimes you may want to actually have the data on-prem. You don't want to have it in a data lake or wherever. You want to have it in a proper relational table, and that's where the data pool comes in. The data pool acts as a cache, and it is, unfortunately, it's append only, so you can only ingest into it. You can ingest through SQL or you can ingest through Spark. And the neat thing with the data pool is that the data is automatically sharded. So it's sharded across as many instances you have. And these instances that we see here, they are normal SQL Server instances. So let's have a look at, we are starting to run a little bit out of time. So let's have a look at the data pool. And we're in my right database. So here I now have a query against that table that I created before, and I'm joining a normal relational table in my in a database here called sales. And since this table is my sort of big data table, it sits remotely. If I execute this, this will take around 20 seconds to execute, because it is it's a fairly complex query from a SQL Server perspective. So that, okay, that wasn't too bad, hey? That took around 11 seconds to execute, right? So, but imagine now that you wanted to create some, you wanted to do analysis, you wanted to create models, you wanted to do this, that, and the other. Maybe you do not want for each run to execute against this data sitting somewhere else, right? That you want to make this a little bit more performant. For that, you have the ability to create a data pool or create a data source against against the data pool. So we're doing that. We are creating, as before, we are creating a table, and the source is SQL data pool, as I named it here. And the distribution is round robin. Remember that I said before that we had multiple instances here. So now what I'm saying is that, hey, across however many instances I have, please round robin your ingestion. So let's create that. Created that. Now what we are doing is we are kind of doing an, well, data federation, data martish thing, where I'm taking some of the data that I'm interested in that was kind of part of my previous query, and I'm ingesting it into my data pool tables. That will take a little while, because we are now querying against my HDFS data. And that took also, well, strangely enough, or not strangely enough, took also around 11 seconds. And just ensure that we have data here. Cool, I have data here. And now let's now execute my query that we had up on top, but this time against my data pool data. And there we go. Right? That took 2 seconds, as opposed to whatever I had up here, 11 seconds. So sometimes it is useful to be able to cache the data, and that's where the data pool comes in. If we're then looking at how this whole data pool thing works, let's execute some. We have a new execute method here at data source. So I'm saying select star from sys databases in my SQL data pool. And when we look at that, come on, we can see that I actually now have here 2 Niels databases. So what happens in the data pool is when I'm doing something with the data pool, I am creating a database with the same name as the database I'm in. And when we're looking at the tables, we can see that we have 2 tables here as well, right? So this is now, because we have now 2 instances of Niels database in the data pool, and therefore we have 2 instances of my clickstream table. And finally, when we're looking here, we can now see when I'm doing space used, we can see that the first table has 292,500 rows, and this has 292,700 rows. So the data has now been sharded out round robin across these 2 tables. Cool. Finally, I'll go through this fairly quickly. So analyzing the data, we have the ability to use Azure Studio notebooks where we are running Spark jobs, both over structured data and unstructured data. And through Spark, I have the ability to execute against SQL Server as well as HDFS, as well as Oracle, Mongo, whatever. And then the job will return data to the notebook. And that's how we now can, so I can use Spark for both ingestion into a data pool, for example, and I can use Spark to do machine learning things against the data we have. So we now see how we can integrate both structured and unstructured. We are ingesting data through Spark streaming, or SQL Server integration services, or our normal insert into. We are storing it in data pools, we're storing it in HDFS, and we're storing it in SQL Server master instance. Then we can prep and train data through Spark, Spark ML, SQL Server machine learning services, and we can store the model in a SQL Server master instance. We can have REST API, containers, etc. And we can now run apps against this. So we have seen how SQL is now, through data virtualization, we are able to combine other relational databases, NoSQL, HDFS together. Through Spark, etc., and Data Lake, we can do machine learning. We can do a lot of stuff. We can manage and integrate the data, and that kind of gives us the whole now manage, integrate, and analyze data of all size and formats. And that's kind of it, boys and girls. So just to sum it up, the data volumes increases by the second, all types and shapes. We have to be able to handle it. If we don't handle it, someone else will. We have seen SQL Server 2019 Big Data Cluster running on Kubernetes. Once again, that is extremely exciting. Go and have a look at Ben's and Anthony's talk at the Data Virtual Summit. In Kubernetes, we're talking about nodes, pods, etc. And Polybase in SQL 2019 works against more storage types, and that is regardless if you're in the big data cluster or if you're in a normal SQL Server 2019 instance, right? And then Apache Spark HDFS is part of SQL Server 2019 big data cluster. And that's kind of me. Once again, thank you to Data Platform Geeks for letting me talk, for letting me run over. Not too bad. And yeah, that's it. If you have any questions, ping me. If you have any questions after this, ping me. You have my email, you have my blog, and that's that. I'll stop sharing now and open up for questions.
Thank you, Niels. Thank you for the wonderful webinar. And I hope all the audience have enjoyed the session to the core. And Niels is also doing a training class at Data Platform Summit 2021 on big data and analytics with SQL Server 2019 Big Data Cluster. It will be a great extension to today's session. So if you wish to really learn more about SQL Server 2019 Big Data Cluster, so the session is there. So DPS 2021 training class. So I request Niels Berglund to talk a little more about your training class at DPS. So what you're going to cover there, quick overview about the modules or something like that.
Cool.
While we wait for the questions.
Yeah, absolutely. I can do that. I hope that I know what I'm going to talk about. No. So absolutely. So that training class, I mean, so this was a 1-hour session where did a whirlwind tour of SQL Server 2019 Big Data Cluster. In the training class, we will look more deeper into to using the data, analyzing the data. What we'll do is we will start with an overview of the big data cluster, a little bit like today, maybe, but in there I will probably go a bit deeper in the whole Kubernetes thing, maybe just a little bit deeper. I will not mention as much about data virtualization in that in the first module. Then we will dive into data virtualization and we will look more in detail of how you do it, what the various options are, what data sources you can have, etc., etc. We will, from there on, we will look at the various now pools that we are talking about, the storage pool and the data pool, what they really are, how we are using them, and how they can help us in our daily job. From there on, we go into Apache Spark, and we get a feel for, so I didn't do anything in this session here. I did have some Apache Spark material, but as we were sort of pressed for time, I didn't do anything. So we look at Apache Spark, what it is, how you're using it, so on and so forth. We will look at how we can, by combining Apache Spark and Apache Kafka, how we can ingest data into a data pool or a storage pool. And this is material that has never been seen before. So let's hope it works as I want it to. Then finally, we look in detail about, okay, so how are you now analyzing data? How are you running Spark machine learning over relational data as well as Hadoop data, right? So that's approximately 8 hours, 4 hours per day, and I am extremely excited to do this.
There is a question, Niels.
Yeah.
Anand?
Yeah. This is an extremely good question. And that's a question I have asked the product teams, both the big data cluster teams and the Synapse product teams. And you are absolutely right that in Synapse we have serverless SQL pools and Spark pools, and We have the same in the big data cluster. Do we have two technologies for a similar thing? Yeah, we do. I mean, come on, this is Microsoft after all. Hey, left hand doesn't know what the right hand is doing. No, that was just, no, I'm joking. So seriously, so if you're, so the big data cluster, so SQL Server 2019 big data cluster is more geared towards if you are on-prem. If you, for one reason or not, you cannot go up to the cloud. If you are on-prem, then 2019 big data cluster is for you, because you can't go to the cloud. You can't use Synapse and Spark pools and good stuff like that on-prem. Right? If you are, however, in the cloud, then there is no real reason to use big data cluster. Then Synapse and Spark pools is probably answer. The reason, just because I am running it here in AKS, is because I'm lazy. I don't have the hardware to run it on-prem, so that's why I run it in the cloud.
So with this, friends, thank you for attending. See you next time. Bye.
Thanks, guys. Bye. Cheers.